So actually I'm a rollup as a service today because Dan Martz was meant to present, but he wanted to scale himself and be at two places at the same time. Asked me quickly to present the slides. Also tried to execute much faster. And yeah, I borrowed the security from him as well, his slides. And we haven't implemented fraud proofs, so if something goes wrong, sorry. All right. This his disclaimer, but I agree with it. So nobody really knows anything about rollups, and we all learned from John. Kind of. I think that this is like the best source of knowledge. I was learning from a lot of his writings to get the knowledge to later try to expand towards L2, so like what we do with the rollups with PBS space and so on. So the types of rollup MEV, well, so any MEV that will happen on chains, both on L1 and L2, will happen from either something that happens on chain as like some kind of arbitrage between dexes, or it can happen off chain as like in the off chain world, the prices keep changing while the blockchain keeps moving quite slowly, like keeps updating every 3 or 10 seconds, and then you have discrepancies between the prices. Also from the cross-domain aspect, like between multiple different L2s, you can have arbitrage opportunities, or the golden example would be, what if the liquidation on chain A can be only invoked if the price on chain B changes and Oracle delivers that information to chain A. So then I can actually, if I can sequence on both, then I can extract cross-chain MEV, because maybe I'm the only one who can move the price on chain B at the same time as invoking the liquidation on chain A. The exogenous MEV. So this is the thing, and here's the example. There was a paper that was showing the example of the $100,000 MEV extraction from simply arbitraging the price of Matic and wrapped Matic between two different chains. Yeah, the more domains, the more different chains you have, the more of these opportunities you have, and the less breached and connected the chains are, the harder it is to extract, and the more. And you simply need to solve it somehow. You need to introduce the tools. There are the shared sequencing or some very advanced PBS, shared sequencing PBS combination, and so on. Within the rollup or within L1, when you think about what brings really these arbitrage opportunities, you can think that the shorter the block time, the more you start behaving like traditional centralized exchange. The less of the arbitrage between the centralized exchanges and decentralized exchanges you have, the less of an arbitrage of a signal from the world and ability to catch up with the signal there is, right? So if there is a natural disaster somewhere that includes some kind of very strong economic signal. Some companies will go bankrupt, some companies will make a lot of money by just rebuilding things and so on. And now if you can react within a millisecond, then it's like barely see the price differences. If you can only take 12 seconds, then a lot of things will happen and people can start taking advantage. So the time matters. And the other thing that matters is volatility. So in a way, kind of a combination of variance and volatility is what defines like how much of the arbitrage you can extract from the given chain. And interestingly, like the fees on chain decrease your abilities to arbitrage. Like the fees will just like remove ability to arbitrage very small movements. So like if you have like small levels of volatility below the fee levels, then like you will just leave the arbitrage because, well, you would pay too much for just swapping there and back. Yeah, so interestingly, that's what I learned from those slides, and it's amazing. Like January 2020, and you have Carl really describing something that we're now introducing, right? So 3 years ago, and we're talking about, oh, we can just borrow the ideas of how to solve the MEV auction from the L1, which at that time we were not doing yet, and move it to L2. And then even here, I think there are some hints of the base rollups, like sequencing on L1, the layer 2 blocks. And here is a mention of Arbitrum. So the Arbitrum does the first come, first served, right? So there's a time boost. It does update it in a kind of sense that you flood Arbitrum with transactions. If they don't time out, then they don't expire. They will be promised to execute. Practically all of them are executed very fast. However, nowadays they are just like batched within this like 250 or 500 milliseconds blocks or X milliseconds blocks, and then reordered by the priority cost auction inside. The thing is, the Arbitrum will say there will never be PBS auction or Arbitrum. However, we have some ideas. Oh, maybe, we'll see. And my slides never have any memes, so I was so happy when I could present Daniel's slides, because for the first time ever, probably I include a meme in my presentation. So it's MEV Boost. MEV Boost is actually, Ethereum 1 MEV Boost, so it's a proposer builder separation. MEV Boost acts as this kind of coordinator of auctions of relayers. So it runs as a sidecar to the validator on Ethereum layer 1. It connects to relayers and says, oh, relay will be sending me different block bids. Whoever builds the best block wins, and I make the most money as a validator. Well, very often you can simply borrow the same design of PBS and push it to layer 1s that are relatively similar to Ethereum. In some other cases, the more differences we have, or what we introduce, the provers, decays, and so on, then less possible it is to just push the same design. Well, this is the description. So Ethereum, as you see, like you can either directly build locally for your execution client, or for MEV Boost, you can connect with all the relays and you create a builder market. The builders compete. They are specialized in building the best blocks, extracting most MEV. So yeah, lots of rollups keep talking about decentralization of sequencer. Like this is like a big thing to deliver. How to decentralize? So decentralize governance, decentralize the breach management, upgrades, decentralize the sequencers, decentralize lots of other things. But here we're talking about decentralization of sequencers. So PBS is a bit of like a first step, because sequencer is both proposer and builder. And the builder is the part where like sequencers may have trouble to get any skill. So what if they can actually delegate this to a market that will find the best solutions in sequencing, and every sequencer has the equal opportunities of accessing this market. So if you have 5 sequencers, either you have a situation when one of them is so good at building blocks that they start dominating and everybody starts staking with them or so, or you delegate it and tell all of them, well, all 5 of you have access to the same quality of blocks. So if you make money, you make more or less on average you'll make the same money, so you can invest the same amount of money in infrastructure, and this is healthy for decentralization. There's a series of, when I saw it in Daniel's presentation, I thought like, oh, I don't really understand it. And then I saw this one and I thought, oh, that's what Daniel meant. Like, I don't understand it because we know nothing about rollups. The idea is here that, well, when we started looking at L2 PBS, we said like, how exactly to do that? So let's try it, all the different complexities. Or I'm guessing. First of all, we have L2 sequencer. This is a centralized one, because this one is better. Then we can think of shared sequencers. So shared sequencers are coming, and this is like, oh, so now I'm shared sequencing between multiple different L2s, usually within the same ecosystem. So it's like an Optimist shared sequencer for all the OP stack rollups. And still, I feel like, okay, what does it mean? Where we go? I guess that's what the meme does. And there's L1 block builder. So after we do sequencing, can we use L1 block builder to sequence? That's for based rollups we can. And where actually MEV Boost goes, like that's PBS design and in what place. And talking about base rollup. So what do you mean by base rollup? So that's something that was discussed a lot, like introduced as a ETH research post by Justin Drake, and now we're talking about base preconfirmations and so on. So the base rollup is a situation when you want to build a block on L2, you construct a transaction representing block on L2, and you send this transaction to the block builder on L1 and say, hey, if my transaction makes it as a first transaction to a smart contract that validates it as a block on L2, then this would be the block that will be accepted as a canonical block on that L2. So think of Tyco. I guess Tyco will do that it has a contract, smart contract deploy in L1. This contract accepts transactions. Whichever transactions wins, comes first, becomes a block on L2, if it's constructed properly. What is very important here is that it means that all the MEV from that block construction L2 goes to the L1 builder. Why? Because if I'm competing with other transactions trying to be the first one to be accepted as a block, I have to start bidding to the L1 builder of how much I will pay them to win. And it means that what I can pay them is actually all the MEV surplus that I constructed. So I take it from the L2 builders myself, L2 proposer, and I push it, I have to pay it to the L1 proposer. All the MEV goes to L1. And now we have L2 block builders. This one I don't get. Okay, one moment. Execution to sequencer. Okay, so that was optimistic rollups. It means that we didn't have a prover there, right? So here we understand what those slides meant. Like, oh, wait, but all that we talked about doesn't have a prover. Does prover make some additional problems? So any of the L2 sequencers, L2 proposers can bring the proofs for the blocks that they are proposing either from a single prover, or maybe like they can themselves be a prover, or can connect to the provers network. And the proofs very often come after a long delay after the block being built and verified. So it may be minutes or hours after the block is being proposed. And the problem is, like, as you start talking about MEV, you all the time think about who do you have to trust that they will not leak your valuable MEV information. So you have alpha in your block and you don't want to share it with anyone. You want to have either encryption, privacy, some kind of protocol mechanism that will detect malicious behaviors. And well, you see that may leak at lots of places. If it's shared sequencer, it means like, oh, like you will send as a block builder, you will send your block to all the decentralized sequencers participating in a shared sequencer network. It will also possibly leak at the prover network. Like, so if you send it to the prover network, says like, hey, who will prove that block for me? They'll say, oh, let me look at this alpha that you have here before I start proving, and maybe even before you submit it. And the same when you deliver it actually to the rollup from your sequencer. And so via relay or something. This I think we can skip. And now a series of proposals from our work at Flashbots and Nethermind in the last few months. So we're looking at how to exactly make some modifications to PBS designs for different networks that would work. So for the OP stack, most likely Optimus will go with a proof of governance. For the proof of governance, you kind of assume that governance already selected the sequencers that can be to some level trusted, or at least will be overseen by the governance, and if they misbehave, they'll be removed, voted out. You can always bring someone more trusted, which means that, well, you don't need to have a trusted relay out of protocol because you're already trusting someone, and because there's so few of them and you accept that they may need to spend more on infrastructure, you can force them to run the relay locally, like relay module, what we call. And then for each of those, you can create a builder market, so connect them to the builders and say, okay, each of us wants to still have the centralization of the builder logic, so we can all make the same money. It's simple. It's like very comparable to Ethereum 1. Just you remove the relay that is like a few relays that are out of protocol and just push them close to the validators. So it's a bit like all the 1 million validators on Ethereum would run their own relay and connect directly to the builders. You don't do that because you cannot govern them the same way as in the proof of governance on Optimus proposal decentralization to like a few proposers. 49 seconds. Aztec proposal, I'll skip it because it's not enough and we're changing it a lot, I think. Tyco is the base rollup proposal. For Tyco, we're proposing the alternating L2 PBS solution. So since it's a base rollup and all the MEV leaks to the L1, can we change it somehow so it actually doesn't? And there is a proposal that you actually can introduce competing two mechanisms. One is permissionless, where you can always pay a bit to say, I override default mechanism, and the default mechanism is a PBS. So you select a set of trusted proposers for Tycho. There are the only ones that are allowed to submit blocks for Tycho within the PBS auction model. So anyone who goes through the auction, for the secret delivery to those proposers, will be protected. Their MEV doesn't leak. But if they want to go permissionless route, they're a bit more exposed because everything is open and distributed via the mempool or via L1 builder, then can pay a bit of a bribe and use that one instead. And there's a description of this one. And it kind of gives you like this spectrum between permissionlessness and permissioned approach, and gives you different results of MEV. And this was the second presentation in case we had more time, but we don't have it. Thank you.